Hi everybody, welcome back. Another Kubernetes Lambda example. In this example, we're going to talk a little bit about the persistent volumes, how to store your application with a pod, with a persistent storage. Let's get started. First of all, what is a persistent volume? A persistent volume, also known as a PV, is a piece of storage in the cluster has been provisioned by admin or dynamically provisioned using storage classes. So this is a one sort of resources in the cluster, just like a worker node in a cluster resources. The persistent volume, just like a plugin to the volume in your storage with some life cycle independently, any individual pod that can be used to persistent volume. So there are API, the object capture the detail of implementation, the storage, such as the NFS, iSCSI, and the cloud provide specific storage like from Amazon and Google, something like that. So as you can see right side, this is the example how to specify your persistent volume with the Kubernetes manifesto. You need to specify the persistent volume as kind, and then there are capacity like a 5Z or 100 megabyte, and the volume access mode, read write once. And then I'm going to talk a little bit about some detail just a bit later. In a summary, you need to manage your consumed storage resources in a static, dynamically provision the persistent volume, and then the pod will request persistent volume claim to consume your persistent volume. So just imagine that your application, for example, microservices application, fundamentally you don't need to have a stateful application, which means you don't need maybe persistent volume, but in some case, a lot of cases in a production reality, you have to store your data into persistence storage, just like a PostgreSQL database or MongoDB or data cache, which keep maintaining your data whenever your pod automatically restarted. That's in the case we really wanted to use a persistent volume. So here are the quick full access modes. So first of all, you can have read write once and read only many, and read write many and read write once pause. So with that mode, you can have IWO, IWOX, and RWX, and RWOP. This is depends on what kind of storage type you're going to use, as well as this is ties to with your storage. For example, iSCSI or network file system or the public cloud storage types. And also you can specify the reclaim policy with the retain, recycle, delete. When you reclaim the persistent volume, for example, you already bind your existing persistent volume with a specific pod like a PostgreSQL, and then when you delete that pod, and then to automatically make re-available your persistent volume. And then sometimes you need to just delete it or reuse that or just retain for the next pod to reattach the existing persistent volume. There are a variety of amount of options, what kind of persistent storage you're going to use with the PV. Here are just a few examples from dynamically provisioning from a public cloud provider. As an example here, the Amazon Elastic Block Store and Azure Disk and Azure File and the Sharp Story File, and then Google Cloud Persistent Disk, also the traditional storage disk like iSCSI and FAS, and then virtual machine volume like a vSphere volume, etc. So let's get right into the demo, how it works. In this example, I'm going to try to use a to-do application based on Quarkus. So first of all, I'm just already start my Minikube status. I just change my existing namespace like a Lambda example, and make sure my Kubernetes namespace is Lambda example. Here's a Minikube dashboard, and go to change my namespace to Lambda example. As you can see, there's no resources I deployed at this moment. And the persistent volume claim PVC, there's nothing in there, and a PV also, I don't have any PV at this moment. Okay, so go back to my ID tool. I already defined Kubernetes manifesto. For example, here's a persistent volume and the kind of persistent volume and the metadata name. And then here's the important part. You need to make sure capacity like a 1 gig, and then also access mode, read write once. And then I'm going to try to use the host path because this is a Minikube. I don't have any external storage type, so I'm going to use the mount on my local file system. That's why I'm using host path here into my template directory. So pretty simple. And then here's a PVC. The same thing, same access mode and same storage capacity. So this is you needed to match between PV and PVC. Here is a deploy example, PostgreSQL, how to use the persistent volume claim. And the one interesting part here, you need to define PostgreSQL username, password, and database name because we're going to use this configuration when you connect from Quarkus Java application. So you can see the database name to do and the username password, which is the same admin just for demo. But in production, you need to specify super secret your password. Okay, and then here's the volume mount inside directory path in the PostgreSQL and the mount to volume, which is the same name of PVC PostgreSQL dash PVC. So this is very simple. And then the last step, I'm going to expose my PostgreSQL pod with the service because I need to access this PostgreSQL from my Java application through service. That's why I expose the port and target port, which is same 5432, and the name is PostgreSQL. The last thing is this is my application to Quarkus pod. Just pull down an existing container registry like a Docker Hub, export port 80. Okay, looks good. And then when you go to my Quarkus application, I just need to make sure the same username password to access the PostgreSQL, which you will be running on Kubernetes. So here's the username password and then the database kind, and then you can see the JDBC URL with your database name to do. Exactly same configuration, and here is the JDBC URL Postgres, which is the same name of a service that I define in the service manifesto YAML file. Here is insert SQL. I'm going to put in the data when you actually application running, it automatically drop and create a new data and schema into PostgreSQL. For data is to create the PV and PVC, and then deploy PostgreSQL with the mount in the PVC storage, and also last thing deploy Quarkus application to access the PostgreSQL. We're gonna make sure this for insert statement will be showed up in Quarkus runtime logs at the end of the day. All right, so go to terminal window and I try to apply to create a new persistent volume first, and just apply a persistent YAML file, and then try to get the resources like a PV. As you can see, new PV just available, and then now try to create the PVC, and then it automatically binds the existing PV. As you can see, it's already bounded, and then you can actually get existing PVC. So you can status is bounded into the same capacity PV. So here's one interesting part. If you just create the 5 gig for persistent volume, but you just maybe need 1 gig PVC, and it automatically bind to any available persistent volume, which is just more than capacity you define in PVC. For example, you define capacity in PVC 1 gig, but there's only available PV is 10 gig, in which it automatically bind into PVC. So just to make sure, if you create the persistent volume manually, add class admin or storage admin, make sure the same capacity make it available. But in order to avoid that kind of manual problem, the storage class you can define dynamically provisioning by cloud provider like Amazon or Google and Microsoft, etc. Okay, now I'm going to deploy PostgreSQL and then export the service as well. Then when you try to get resources here, that part, and then you can have that PostgreSQL is running, you can actually find the logs using kubectl logs that part, and you can see the all PostgreSQL just started without errors. When you go to Minikube dashboard, you can find the PostgreSQL logs. You can find the same logs is starting without any errors. Okay, looks good. Now I'm going to try to deploy a Quarkus application using kubectl, apply to the application, and then go back to dashboard, and then go to pod, and then you can have two pods running. When you go to Quarkus pod logs, you can find the first SQL statement is already there, which means this Quarkus pod can connect to PostgreSQL through service name, which is really cool. Okay, today I run how to create a persistent volume for your stateful application like a database or data cache, the Kubernetes. Hope you see next NumPy example. Thanks for watching.